the application that I wrote, Vulnerability Notifications for MidnightBSD. First, we'll go over the introduction, then the architecture, a demo of the application, a summary, and some references. So first, what is MidnightBSD? MidnightBSD is a desktop operating system originally based on FreeBSD. I started the project in late 2005 to build a desktop system similar to Mac OS X. The architectures that MidnightBSD runs on are 32-bit and 64-bit Intel processors. MidnightBSD includes a package manager to install software packages. This is kind of similar to what you'd find in a Linux distro like Debian with apt-get, Yum, and Red Hat, and so on. The software is, normally when you install software on MidnightBSD, you do that with the import command line tool, a graphical application to manage ports, or you can manually compile software on the system similar to, Gentoo on Linux or FreeBSD, where you just build software based on predefined makefiles that the project provides for you. So even if you install from ports, it's installed through a package. The reason that this is important is that the utility makes use of the package infrastructure to kind of do the vulnerability checks that I'm going to present in a moment. So what is the NVD? NVD is the National Vulnerability Database, which is an online database of CVE feeds as well as CVSS base scores and the vulnerable product configurations and weakness categorization. So basically, every vulnerability is scored in a couple different ways with a simple severity of high, medium, low, as well as a floating point value between 0 and 10, and so on. It's provided by the National Institute of Standards and Technology, or NIST. The files are available as RSS feeds, which contain the last week's worth of data, XML feeds, which they provide a yearly file as well as a recently modified file, and also in the JSON format. The database is available on their website as a dump, or you can query it or look up individual vulnerabilities on the site. Here's an example of a JSON formatted output file from the NVD data. As you can see, there's individual list of CVE items, so each CVE is a vulnerability. You can see it has a unique identifier of CVE 2018-0001, for instance. You can see the vendor name is present, so Juniper with JuneOS, and these are the vulnerable versions of JuneOS. For those of you that don't know, JuneOS is an operating system that's found on Juniper routers and switches and firewall products based on FreeBSD. So when I was looking at this project, I kind of looked at some similar things out there, and FreeBSD has a project called VUXML, or the Vulnerability and Exposure Markup Language. So basically they have like an XML format of vulnerabilities, and then they tag them with metadata about what packages in the FreeBSD system are related to that vulnerability. So basically like a fixed version of the package. The reason that they need to do that is that in some cases they'll apply local patches into their Subversion repository for the software rather than updating to the latest version. Perhaps it's not available yet, or there's just a patch file out there so far. So this is kind of an intermediate step. So when you're doing version checks, you would have to look to see if this fixed version is included. So this XML format was kind of interesting, but it felt a little bit heavyweight being XML and overly complicated. So I decided to implement something from scratch. Now we're going to talk a little about the architecture of the application that I built. So when I was looking at how I could process this NVD data, the JSON format that they're providing is new and experimental or beta, and so they've said that the format could change. They could add additional fields or change the structure. So that was a concern for me, is that I didn't want to have people install this application on their individual computers and then have it go out of date quickly and not work or function properly. The files themselves are available both in gzip and zip formats, but I noticed on several occasions, including this past weekend, that the proxy server they have between their file storage and their front-end web server kept going down, and so we were getting all sorts of errors trying to fetch files, which makes it kind of difficult to test. So another concern that I had was, how could I kind of cache this information in a format that would be easier to use for individual systems that are querying it. So I decided that the solution to this problem was to build my own REST API that you could query and have a database storage engine kind of keep a local copy of their data. So I built an application using the Spring framework in Java, which uses a Postgres backend database in Amazon, an Elasticsearch instance for text searching, which is an embedded text search engine that Spring Data Elasticsearch allows you to use. I had an existing Amazon EC2 instance web server in Apache, so I spun up a new app server that's running FreeBSD 11.1 release and OpenJDK 8, and the Spring Boot application that I've built is a self-contained jar file that includes an embedded Tomcat, and it runs with Spring MVC and Spring Data plus Hibernate. The additional kind of piece to this is, what does the individual user use on their system? So we needed a way to check for vulnerabilities on installed software. We wanted to email notifications, if possible, to individual users. So you could kind of have like a daily report of what's vulnerable rather than having to proactively log in every day and check it. We wanted a command line tool to kind of manually check if something is vulnerable in the system, and a way to scan existing software packages that I've installed using the import system and verify that individual versions are available. So, if I've got a version of, say, PNG library installed and there's a vulnerability in it, I want to know that, and I need to know what versions are affected so that I could potentially update my software. So what I decided to do was, I wrote a Perl script that I called advisory.pl, which kind of pulls data from the import command line tool, which is the package manager, and it compares the individual versions of installed packages against the database. Now, this requires that the packages have to be tagged with the vendor and the name of the software package, as well as the version number. Not all packages have that information available yet. For the purposes of this demo later, I installed about 15 packages or so, just so you could kind of see on a real server what vulnerabilities exist in the packages. The individual advisory PL will do a REST call for each individual package installed in the system and check for all of the vulnerabilities for that package. I also wrote a shell script that can run out of the periodic cron job that runs every day, and that is set up to automatically email the results at the end of the run. So this satisfies the email notification aspect, so it ties into the periodic system, which I can kind of demo that as well. The app is also available as a package in the MidnightBSD system, so that you can install it, so you can actually get the advisory client built in. And I've put all the source code for this available on GitHub, and I'll provide the links for that at the end of the presentation. I had a couple difficulties with this project. The first was being that the NVD website kept, having issues with those packages, or the zip files not being available. Individual packages had to be tagged with the vendor metadata. So for instance, if you're looking at GNU bin utils, I needed a tag that GNU was the vendor in order to find it correctly in the database. So there'll have to be additional work to kind of tag all the packages with the vendors, so that future updates will allow you to check more packages for vulnerabilities. The single biggest problem I had though was the version checks. So every operating every package has a different naming convention. So, one open source project might go with 1.0.0, another one might be 1.0, another one might be 1.0b, where you have a letter in there. Bind, for example, uses 9.10.0 P2, so patch level 2. So there's all sorts of crazy variations. So the solution to that problem turned out to be looking at each individual piece of the version number and kind of separate it on dots into an array, and then process them all, and then transform the letters into numeric values, so the characters would be used. And I can show you how that code works in a moment. Next, we're going to look at the demo. So first, I'm going to show you the output from the API. This is what, so this is sec.midnightbsd.org/API/advisory, in case you guys can't see that well. So this is a JSON response from the API. So this is a paged response. So there's about 41,000 vulnerabilities in here. So this is pretty much everything since 1999 has been loaded into the system. Not just Unix-specific vulnerabilities either. I've decided to just load everything, and this API is completely public and anyone can query it. So when you do an individual URL like this, where you specify the vendor of GNU and the product name is binutils, it gives you a list of every single vulnerability that's ever been found in binutils. And so this endpoint is actually what my script is currently using. So this is the NIST website, and you can see here that this is the JSON feeds that they have. So they have gzip versions of all of them, which is what I'm fetching. And you can get a version back to 2002, and this actually includes older data as well. So it goes all the way back to 1999. So I've populated all of these files into my own system. So this is actually the Perl script that is on the client. And let me pull this back up. So you can see here, effectively what we're doing is we're using the import command line tool to pull a list of individual vulnerability lines, which looks like this. So you have the vendor of GNU, the product is gmake, and here's the version number. So these three fields I pull out, and I do a query. So get issues here will call my REST API, passing it the vendor and the product name, and then it loops through the individual objects and compares the version numbers. And I'll show you the version algorithm in a moment. If the package is vulnerable, it will print out the vulnerable package name, the individual CVE ID, the description of the issue, and the severity, so you can make a decision whether or not you want to update your packages or if you can wait to do it. So you can see here that this is the actual REST call that we're doing. So I'm using this Perl library to make the REST call, and it gets a JSON response back, which it decodes into an object, and then I go through and process it. So the version algorithm is right here, and you can see that I loop through and do comparisons of each individual version, and I determine if it's numeric. I can just do an equality and be done with it. If it's not numeric, then it does the string algorithm, which tries to break it up and does a transformation of individual values. So it will turn strings into numeric values and so on. So here's the algorithm right here. So if the particular part of the version number is numeric, then it just uses it effectively. If it's a letter, it gets the ASCII value of it. And if it's kind of like a non-letter character, so an exclamation point, a special character of some kind, it gets the value and adds 128 to it. So it's just kind of out of the normal ASCII range. So this kind of allows it to do unique evaluation of it. So if I run the utility, you can see there's quite a few vulnerabilities on the system. BinUtils has multiple vulnerabilities. We also have Dovecot, which is an IMAP client, and the NTB daemon OpenSSL, Perl compatible regular expressions, and it prints out the individual text and severity level. So I can go through now and kind of update those individual items. So if I go into Etsy Periodic Daily, you can see that I've installed this advisory import module. So this is the actual shell script that runs the utility, and the output from this will automatically be emailed by the periodic system daily, as I mentioned before. Pretty simple script, actually. So the import CPE command that the script is running will output each individual package. So this is the vendor, the version, and so on for everything that I've got installed that's tagged currently. If I compare that to the list of things that I actually have installed on the system, you can see there's a lot more here. So over time, I hope to get more of these tagged. So that's kind of how the actual script works. Let's look at the source code now. So first, I've got the individual tables are listed here in the Postgres database. You can kind of see what we've got there. And I can show you, this is the actual code. So the key part here is this is the fetch service. So this actually goes out and fetches individual NVD files. So it's got some drivers here. So this daily script runs once a day, and it fetches the latest recent file from their system. So this is kind of the name of the file. And so it's on a schedule like a cron, and it calls the import service with that parameter. And it will go through and pull the data and look at all these different fields and kind of simplify it down. So if I pull at this advisory model here, you can see that this is the actual fields I'm storing in the database. So we have the published date, the last modified date, the severity, the problem type, the fixed packages, which I haven't implemented yet, but that's a similar concept to what FreeBSD was doing, where it allows me to tag that a certain package is available in MidnightBSD that solves the problem. Currently, it just assumes if the version number is higher that it's been patched. And then a list of products, which is stored in another table. So this is like a many-to-many relationship. So each individual product is here. So we have the name and the version number, and then we have another table to store the vendors, which also have the name in it. So this is kind of a nice way to kind of break everything up. So going through the individual items here, it figures out the severity and so on, and pulls all that data together and saves it into the database using the ORM software. So if I go into the service layer, you can see the description, the last modified date, all these things are getting set in here. And it tries to do update detection so that it's not saving every time the job runs if the data hasn't actually changed in the database. We also go through and attempt to index. I have that disabled right now for performance reasons, as my AWS instance is kind of small, but there is actually a job that runs daily that does a full index anyway. This is just commented out for the individual items. So that's kind of the key part of the application. You can see the database structure. So I'm using a third-party add-on that allows it to automatically update the database configuration. So this is kind of the initial configuration I went with the table schema and so on. You can kind of see how that works. These are all the classes I had to create to map the NVD fields in that JSON that I showed earlier into individual objects. So it turns it into objects and then it transforms it. And then we have the controller, which actually calls the services. So this exposes all of the REST endpoints that we showed earlier. Okay, so in summary, the NIST NVD data provides helpful resources of threats with data going back to 1999. The details include the vendor, product name, version, configurations, descriptions, and severity ratings. The MidnightBSD Package Manager import can be used along with this new Utility Advisory PL to scan your system for threats, and it can also notify you via email through that automated periodic process. Support for tagging fixed versions is still needed, as well as tagging the individual vendors on some of the packages. And finally, here's the list of references. So the MidnightBSD website, if you want to check that out, the data feeds website. This is the Subversion repository where I put the port so you can install your the advisory client on your local MidnightBSD install. The source code for the client as well as the Spring Boot application are available on GitHub here, and you can see the VU XML. Thanks for watching.